This is question number 3 of the SACE Stage 2 Physics course companion from Subtopics 2.3 and 2.4. Here we have a current carrying conductor carrying current I and 2 points around the conductor. S is 2 micrometers away from the conductor and has a magnetic field strength of 3B, and T is some other distance D from the conductor with a magnetic field strength of B. First, what we need to do is determine the direction of the magnetic field at points S and T. So here, if we just redraw this, the current going towards the right, using your right-hand curl rule, if the current is going towards the right, then the thumb's in the direction towards the right, and your fingers kind of curl around, showing the direction of the magnetic field. That means above the conductor, the field will be coming out of the page, so we can draw dots showing that direction, and below the conductor we're going into the page, so we can draw crosses showing that direction, kind of like an arrow coming into or out of the page. Now at point T, which is up here somewhere, the magnetic field strength will be directed out of the page. So here we'll just go out of plane of the page, and S, which is some point in here, the magnetic field is directed into the page. So into the page, plane of the page, and that's fairly easy. Once you know the rule, there's not really much else to it. After that, we need to determine the distance D. This is seems a little bit tricky, but it's actually not too bad. It's kind of like a proportionality type question. It just requires you to think through what you're given, and then after you go through that, you can sort of work out what you need to do. So we'll start off with our formula for the magnetic field strength due to a current. So B equals mu naught on 2 pi multiplied by I on R. Now looking at this, we can see that both mu naught on 2 pi and the current are constant, and it's only R and B which vary. So one way of doing these sorts of questions, and proportionality questions in general, we can rearrange to give everything that's constant on one side and everything else on the other. If we do this, we can see that BR equals mu naught on 2 pi multiplied by I, which is constant. Therefore, for any distance R, we can work out the magnetic field strength using this kind of relationship. So in terms of proportionality, we can write this as B1 R1 equals B2 R2. Here we're not talking about 1 and 2, we'll talk about S and T, so we can write the magnetic field at S multiplied the distance at S is equal to the magnetic field strength at T multiplied by the distance from the conductor to T. Now we can just substitute what we're given. So we're told in the question that S, the magnetic field strength is 3B, and at T the magnetic field strength is just B. So we can just put these values in, so 3B multiplied by that distance, which is 2 micrometers, equals B multiplied by the distance to T. So straight away the magnetic field strength values cancel out, and it's easy enough to calculate T, the distance to T, so it's just 2 times 2 micrometers, which would just be 6 times 10 to the power of minus 6 meters, which we'll write as 6 micrometers. And that's it. It's a fairly easy question. There's a few conceptual things going on which makes it difficult, but the actual calculations themselves are not too bad. Getting started is probably the most difficult part of this question.